Right, this is a brief introduction to using Linux. It might appear good idea to use Windows, and there's nothing wrong with Windows, but we're going to play around with the Linux system with our web servers. And look at two sorts of web servers: a Linux web server called a LAMP, Linux Apache MySQL PHP, and the AAS is the Windows web server. Windows web servers AAS runs inside Windows. Obviously there are icons, there are drop downs, there are right clicks, there are settings and all sorts of jolly stuff like this. It's fine. If I'm going to run a Linux web server, it's not going to happen like this. What I want to do is just run a Linux web server and nothing else, only the web server, end of story. So there'll be the web server, perhaps a database, perhaps some sort of word processor, some control stuff, only what I absolutely need. And what I don't need is a graphical user interface. So most of them just sits there and there's a black screen and I can type on it. So we're going to have no icons, no right clicks, no properties windows and stuff like this. We're going to get the hang of how the Linux console works and what the basic commands are. Now, open source doesn't necessarily mean free, but many of these are free. OpenOffice is now packaged as LibreOffice. There was a branching movement of two separate schools of running it, basically. These are all graphical things. GIMP is drawing. Windows, icons, minimize, maximize, it's fine. OpenOffice, LibreOffice, the GIMP, they're free and they work. Nano and Gedit are text editing. Gedit is graphical. Nano will work with just a console and spaces and words. It's not always installed with Linux though, but it is quite handy. It's relatively straightforward, relatively makes sense. We'll more often be using a program called Vi, which is a bit in your face, but it does what it says in the tin. It's simple, it's almost always there. So, they will save, the GIMP will save in things like JPEGs and so forth. OpenOffice or LibreOffice will save in formats such as doc and docx. So you can work on a graphical Linux system and save with stuff. If you've got a non-graphical Linux, you're out like it's not going to happen. Some people say free software, get what you pay for. They might not be quite as smooth. Now, some are darn good, but sometimes they're not quite as smooth as Windows stuff. So there may be certain issues in moving files around or saving stuff. What I sometimes get is I might write something in LibreOffice with a table and layout, stuff like this, and it will save as docx, and brilliantly Windows can open it, but it's messed up a tiny bit. The boxes aren't quite where I thought they were going to be. It's not perfect. But if we've got a graphical Linux system, we can get files off it, a common one. Graphical Windows system, need a screen print to explain what's going on. We can screen print it, save it as PNG or whatever, remove it, put it into Windows if we need be, and start it up in there. Transferring files is usually not too bad. If it's in the same hard drive sort of simple system, it's okay. But if you're going to put in a USB stick or some sort of external drive, you have to mount the files. So if you've got a Linux machine and you're putting a USB stick inside it, it should auto mount. If it doesn't, there's a mount command. But the warning I should give is that don't pull your USB stick straight out of a Linux machine, because if you haven't unmounted it, at best it won't save the information, at worst it can't be responsible, it messes up. So you have to physically unmount external drives in the Linux. Now, in most graphical Linux, it's running more than one console at once, and you can move between the consoles. This is for Ubuntu. Control-Alt F1 through F4 are consoles, black and white stuff. Control-Alt F7 is the graphical one. If it just happens to go all horribly pear-shaped and wrong, possibly all you've got is the console-based thing up there. So, for example, I did something stupid recently. A Linux machine and put a new graphic card in it and installed the graphic card drivers. And it wasn't a happy solution, I'll tell you this. It was all bad things happened. So I thought, okay, let's pull the graphic card out. And I did that. And unfortunately, it left the graphics card drivers in, but the graphics card wasn't there. So Ubuntu tried to boot into its graphics that wasn't there, and it gave up. It didn't want to know. So I tried and work on the console, which is all I got for quite a while, to find the files, delete them and reset them, so it could pick up back to its default graphics and then go into default GUI, and I could play around with this. But for a while there was nothing but a console screen to work with, and when I could get that fixed, up would appear the graphics again. We're going to have more than one terminal up there. It usually asks for a login. Often in many machines, set up student has been a good way to play around with whatever you want, basically. There are certain commands, such as pwd is print working directory, ls list files, who's logged on, exit, close the terminal. Case sensitive, and if there's a gap, there's supposed to be a gap. So don't put any white space that shouldn't be in there. Some are just a single word, like who, that just tells you who's logged on. Others, Nano expects something, so Nano expects you to create something that will create a file called myfile, could write inside it. Others are switches. RM is remove, -R recursively my directory. Should, given luck, remove a directory called my directory. Now if you've not got one, it won't do it. But this will remove my directory and all the files inside it. That's what the -R means. If I just did RM my directory, it would probably crash if there was files inside it. But this will remove it and the stuff inside it. You can chain one command to another to another. So a whole line of various commands and run them all together. And it can work in one line, which might seem a bit, yeah, it's clever, but who cares? But you can take that chain of commands and save it as a shell script, and then run that shell script. So you're running a load of commands with one basic timed command or one instruction. There's a fair degree of power that does. Here are some of the commands we'll play around with, and some useful stuff up there. The cursor arrow, putting up, goes through the history of commands. So say you did a command like touch my file, which means create a file called my file. You want to run that command again, you arrow up through your previous commands and find what you want it to. Tab will complete things. So say you think it was called nano, was it called nanar or nani or nanotomy? You type NAN tab and it will create the thing for you. So I know that files, usernames are stored in /etc/password. So if I do /et/et and tab it, it should put in /et/password for me. It's an awful lot of trouble. Minus help if you're desperate, so I could do nano minus help, so we help on nano. Touch creates a file. Echo just echoes things, so I could do echo my screen, which puts the word my screen. There is a purpose. Move MV moves a file. CP copies a file. RM removes a file. There's no rename. If I want to rename a file from my file to your file, I'd do MV my file your file, which in effect renames the file my file your name. MKDIR make directory, RMDIR remove directory. Nano is creating a file thing. RMDIR will remove an empty directory, won't remove a full one. If I use RM -R, it will remove a directory and its contents. We'll play with some of these in a while. Useful tricks. You have a console, it fills up full of your previous commands, lots, and you get lost and mess up. Control L will clear it up. Not on your Control U will remove whatever you've typed. So you'll type and sometimes it's not echoed, so there's nothing on the screen. So it'll ask for your password, you put your password in, but it won't show your password as stars, you just type it's in there. If you think you've messed up your password, Control U clears off the cursor back to normal and type your password in from scratch. We can manipulate multiple files, so this will create files that start strawberry, banana, apples, small, medium, large. So I do strawberry, small, strawberry, medium, strawberry, large, banana, small, banana, medium, banana, large, apple, small, apple, medium, apple, large, all those files created at once. ls-a will show hidden files, files to begin with a dot are normally hidden. These are wildcards, so rm*.txt will destroy or remove all files that end in txt.